Class. Today we're going to be focusing on lesson 9.2a, and we're going to be learning about the general form of the quadratic equation. We're going to split this into two parts, basically focusing on two essential questions. The first essential question is, what is the standard form of the equation? And the second part is, how do you graph an equation in standard form? We're going to connect graphing in standard form with the vertex that we learned about in yesterday's lesson. So to begin, we are going to take a look at part one, and part one is, what is the standard form? So by definition, or what standard form implies, is the standard form of a quadratic equation must meet these criteria. All terms must be combined. Terms being combined means all the x squared terms are together and all the x terms are together. The second part is, as we move from left to right, each term must drop by a degree. So that means x squared, x, and then you would have x to the 0, which is technically doesn't show up. So in general, we say that the standard form of a polynomial is y equals ax squared plus bx plus c. Okay, notice that the degrees are decreasing each time, and there are no repeated variables such as 2x squared showing up. Note that a, b, and c are simply numbers, and that the c value is always going to be the y-intercept of the graph. This is going to become more important as we continue our learning. So let's take a look at two examples. The first example is asking, is this in standard form? So I check, are there any repeated variables? No. Are the degrees going down? Yes. Therefore, it is in standard form. Next, I can figure out the coefficients. So the number in front of the x squared is 8. The number in front of the x is negative 10. And the last number by itself is 3. So I've now identified the a, b, and c of that equation. Next, is this in standard form? Now, some of you might say no, because it doesn't have an x term. But technically, we can write it with an x term. We just write it with a 0x. That allows for us to have it be in descending order. The reason it doesn't show up here is because they're ignoring that 0x, because anything times 0 is 0 and would not show up in the equation. So is this in standard form? Yes. And our a value is 4, our b value is 0, and our c value is negative 9. Now that we've gotten more familiar with how to identify the a, b, and c, we're going to move into part 2 of this lesson, which is looking at how would you graph an equation in this form. Now, we can always create a table, but sometimes it's nice to be able to narrow in where is the center of this particular quadratic function. So we're going to take a look at this equation as we do this. And to begin, we're going to find the axis of symmetry. The axis of symmetry has dual purpose. It is the x value, or sometimes referred to as the h value of the vertex. And we can find this by taking the b value divided by 2a. This relationship is going to come back later on when we start doing some solving. So finding the equation, or the x value of this, is going to just happen using the a, b, and c value. So a in this problem is 1, b is 12, and c is 32. Now in this shortcut, we do not need to know what the c is. That is not necessary. But we do need the a and the b. So finding this value, or the x value of your vertex, we would go ahead and say x equals negative 12 divided by 2 times 1. Well, negative 12 divided by 2 is negative 6. Now that we know the x value of the vertex, or the axis of symmetry, we can solve and find its y partner. So we know that x is negative 6. We need to find its y partner. To do this, we plug negative 6 in for all the x's from our original equation. Remember, this is the equation we are working with. So plugging in all of those values, for -6 for all the x's gives us -6 squared plus 12 times -6 plus 32. That gives us 36 minus 72 plus 32. And when I simplify that or combine it, I get -4. We've now found the vertex or the lowest point of this equation. In my table, I'm going to put in that -4. From here, you can find all the remaining values by plugging each of these in for the x value. I'm going to show you that right below here. So we would go ahead and take and plug in -8 squared plus 12 times -8 plus 32. When I do all that math on the calculator, just type it in with the parentheses around it, you should get 0 out. Plugging in -7 next. -7 squared plus 12 times -7 plus 32. When you type that into the calculator, you get -3. Now, as we've learned, the axis of symmetry cuts this graph in half, which means this is also -3. And if I were to plug in -4, I would get 0 out. If you want to, you can sketch the graph, but it's going to resemble the same graph we saw yesterday, a U-shaped graph that was translated to the left 6 and down 4. I hope this lesson helps you see how to find the vertex when given the general form and how to graph it.